Hi guys, so we're going to be solving the source-free RL circuit. So in this particular case, they want us to find I of t, and I of t is given by the formula I naught e raised power minus t over tau. Let me just explain the formula a bit. You see, they said find IT when t is greater than 0. That means after you have disconnected the battery and then the inductor has started to discharge some current, because immediately you disconnect the switch, the inductor does not immediately start discharging current. It's after like t greater than 0 the inductor really starts discharging its current. And so this I of t is at t greater than 0. That means the switch has been opened. When the switch has been opened, the current source in this circuit, this just be the circuit now, that particular place is gone now because of this open switch there. So the current source in this particular circuit is only the inductor. So the inductor is acting as the initial current in the circuit now at t greater than 0. So it's actually the current in the inductor that will be here. And then the reason why it's e raised power negative this thing, you go online and check for the graph of e raised power negative 2. You see that it's a kind of decremental graph, decrementing exponentially. So as you disconnect the battery, the current begins to go down. That is why there's this formula here. So I just want you to understand the formula a bit. So the first thing you want to do is you want to find tau for extra marks. It's RL over REQ. So to find REQ, you always find REQ after the switch has been opened. So after the switch open, remember this is the only circuit that we will now have, because this is open. If current comes here, the current will just hang here. So any current cannot flow in this entire circuit. It's condemned. So to find REQ, we simply just have these three resistors. I can see that this is in series with this. After they combine 12 plus 8, that's 20. I can see that it will not become in parallel with 5. Look at it. Let's say they combine. This is 5 ohms, this is the 20 ohms. Because students get confused with this thing. You may think it's in series, but actually they share two common nodes. That automatically makes them parallel. So that's what defines a parallel circuit, or rather resistors in parallel. So it's in parallel of 5, so it becomes 4 ohms. Tau, that's time constant, to be equals to 2, which is the value for the inductor, over 4. So it's going to be half, or 0.5 seconds. So now we need to find IO. To find IO is simply the initial, like I already explained, is the initial current in the inductor after the switch has been opened. So in order to find this, we actually have to close the switch and find out, okay, what was actually the current in it just before the switch opened. I really hope I'm making sense. So when you connect back the circuit, I would like to redraw it. When an inductor is connected to a DC source, direct current source, it acts as a short circuit. We're going to replace this line with just a line. It's a short circuit now. And then you simply just find the current at that point. In this case, current is I naught because that's the current flowing through this part, through the inductor. Okay, and now since this has been short circuited, right? One thing you should know is that short circuits affect whatever is in parallel with them. So because for circuits in parallel, I'm just going to explain this. For circuits in parallel, the voltage here is the same as the voltage here. A short circuit means what voltage is equals to 0. So therefore, if a short circuit is point V equals to 0, surely here must be V equals to 0. So in this particular case, and in this particular case, this shares a common node with this. These two objects are actually in parallel, which means this 5 ohms is going to get condemned. So it comes useless. So we can just remove from the circuit. It comes just a straight line because no voltage there. That means no current will be there as well. You can honestly just remove the entire line at once just to make the calculation easier. Now I'm going to actually use nodal analysis. If you do not understand nodal analysis, you can just watch my videos. So I just identify my node. All of this is a node. All of this is one node. Why? Because they are all connected by just a wire. There's no element in between them. So I'll just call it VA. So what are the currents entering this node? I know this is entering the node. 6 amps enters the node and then it exits at these positions. So when it goes in, it spreads its wings to this point, comes down here, reaches here, comes down here, and reaches the edge, comes down here. So the nodal equation is simply going to be 6 equals to VA over 2 volts, sorry, 24 ohms. That is for this first one, the current flowing through it, plus this point is going to be VA over 12, VA minus 0, but I'm just not writing the 0, plus VA over 8. You solve for it, you're going to get your final answer of 144 equals 6 VA. VA is equals to 24 volts. You can just simplify the equation. Now that we know what VA is, we know that this current I naught is the current flowing in this particular line. That I naught is actually equals to the voltage here minus the voltage here divided by whatever resistance there. So it's VA minus 0 over 12. So VA is going to be 24 over 12, 2 amps. So this is 2 amps. So now going back to the for my equation, IT is going to be equal to what? 2 amps E raised to power negative T over what's tau 0.5, and can become 2 E raised to power minus 2 T amps. This is much preferable. So this is your final answer. Thank you so much for listening. I really hope you understood what I explained. Thank you.